going to take you through some of the developer experience when it matters to the cloud native computing. So when we talk about cloud native computing, probably we should also take a recap on the cloud computing itself. So one of the experience I had is maybe 5 years ago also when I was interviewing students from colleges. Uh, One of the first questions I ask is, what is cloud in your opinion? So the answers I get is very interesting. Cloud is a storage for storing photos or things like that. So I used to keep probing and asking other questions to get some other sense about cloud computing. But the perception about cloud around that time is only for storing data and things like that, largely around global storage or centralized storage. Uh, Partly to do with cloud was not very famous or popular in universities at that point in time, though it was still a good hot topic in the industry. But now things have totally changed. Everybody, even a child, knows what is a cloud. So cloud is a computing platform for high efficiency, which is the accumulation of the knowledge in the industry over the last many decades. Efficiency, operational efficiency in all the aspects, including software development lifecycle. So, over the last many years, we have seen the proliferation of platforms, technologies, frameworks, tools, and languages which are specifically crafted for the cloud computation. And then a lot of players, companies, organizations, communities, people, developers, students, everybody poured in to see, to extract what is the best out of that platform and the technology. And here is the result of that. I'm sure many of you have seen this. Can you please raise your hand? Anybody seen this? Yeah. This is called the cloud native landscape. And the vague picture here shows the tile, shows the investment. Each tiny tile represents a player in the platform. It can be a billion-dollar company, it can be a tiny startup. But the whole idea is cloud native landscape is quite huge and it is the technology, the platform of the decade. Did I mention somewhere 20 trillion is the capital investment that's flowing in? That means a huge, a huge portion of the industry is focusing on this area. And that's one of the main reasons why we as developers should be taking this seriously and investing our time and effort on this platform. Our company, IBM, I don't see we can locate it. It's just a tile here. So that shows how deep and how wide is the platform. Now let's go back and take a fundamental definition of what it means fully open cloud native Java development or Java stack actually mean. So these are the recipes which I thought that should qualify for being called as a cloud native Java application development. First one should be open standard for end-to-end components. This is very, very important. If you have been developing for some time, you know that when you consume some module from the ecosystem, you need complete support, you need complete feature capability, you need security, compliance, and all sort of things. Now, if that is being provided by one specific vendor, after some time, when you want to enhance your product, when you want to get some support, you see all the terms and conditions of the vendor, and you always get into some sort of a trouble. Migration become difficult, enhancement become difficult, sustenance, maintenance, support, everything can become a hell if it's a closed source dependency. And we have seen it. Open source has been the norm of the day over the last 20 plus years. So this is very trivial now. Second one, the runtime platform should be optimized for the cloud. So as we know, Java is 25 plus years old, and initially it was never designed for cloud. It was looking at abstracting the machine to the best possible extent. The keyword, when anybody talks about Java, the first one comes is platform independence, nothing else, right? So at that time, 90s, each language or each platform used to focus on specific platforms. Portability was a major issue, but now that is taken for granted. The main thing is how fast, how efficiently your platform is going to run in a container or in a cloud. So Java shouldn't be the old Java 1.2 or 1.5. It should be highly optimized for the containerized workloads. The third, open source vendor support. So I will combine third and fifth together because it's more or less related. Uh, if you have been consuming open source components or if you have been providing open source components, I am both. I'm a producer as well as a consumer. One of the main pain point with the open source as perceived by me is you need a capability. It may be an authentication, it may be a database connectivity, it can be a AI/ML capability whatsoever. You go and search in your favorite registry, Maven, NPM, wherever, you get it. You get few of alternatives, you consume it happily, everything works fine. But 6 months down the line, 1 year down the line, you get a bug in that, you raise a bug with the community, you find out which is the project which is doing this development, you get no answers, right? Your product is mission critical, but the upstream project, they don't care about your product, right? They say you can't push hard. We are all working in a voluntary basis, right? They may respond overnight if you are lucky. They may respond after 1 week. They may respond after 6 months. They may not respond you at all. They may close your bug, deeming with various interesting reasons. So open source is good in terms of vendor lock-in problems and other things, but open source dependency modules should be matured and what I say, it should be dependable, trustworthy. It should be sustainable in the long term, right? So you need to be cautious about what module you're consuming, who are the vendors or the developers or the committers who are having ownership on that module, and what is their maturity stability cycle or state. Are they going to provide a long-term support for your security concerns, your capability concerns, and things like that? So this is third and fifth becomes absolutely important when it comes to cloud native Java stack. And components inherently designed for cloud native services. Everything is good, everything compliant, secure, long-term supported, fine. But the module that you are depending on is a huge monolith which was written 20 years ago. Your microservice is tiny, 10 lines of Java code, but the dependent library is a huge 2 MB jar. So everything is refuted, everything is violated, right? When you load your container, it's coming as a 2 GB memory. So the whole ecosystem in which you are developing, deploying, and running and testing and debugging should align with the cloud native philosophy and the principles. Then only it gives you the complete optimal efficiency when it comes to the whole stack in the runtime, right? So these are the ingredients or recipes I came up with for us to be calling cloud native stack or cloud native application development lifecycle. Now, in today's session, we are going to see what are the tools and frameworks, what the people have been doing, what the organization have been doing, what are the learnings from the open source community, cloud native community, and how do you support the developer, how do you support the programmer to the best possible extent so that their life is easy, their life is not prone to such problems that we described here. So we'll have a demo. Mohan will be taking us through that. But before that, we'll talk about some of the community-driven initiatives to address these problems. So the first one is Eclipse Foundation. I guess you know about it. It's a foundation. Foundation is nothing but a governing body over and above the open source project. Open source project is good set of engineers who came together to develop a piece of code, but they are not tied under a payroll, so they are not bound to each other under any code of conduct or anything. A governing body such as a foundation make sure that the engineers have sufficient supply of resources, support, um, finance, whatsoever, and there is a code of conduct in place so that the development life cycle of the open source is going smooth. Right. Eclipse Foundation is one of the largest and oldest matured open source governing foundation, which has a lot of industry leading experts as its member companies to make sure that the development in these organizations going smooth. Next slide, please. Largely Java based, but it's not bound to Java as such. I just took a screenshot from the list of projects that this foundation is governing to show you a feel about what is the coverage. So each page is having 20, 25 projects into 21. So 22, you get around 400 projects under the Eclipse Foundation umbrella. Eclipse platform, which is the IDE that most of us familiar are, is the one which is highlighted. And the drop down shows which are the areas or the themes in which this foundation is focusing on. So clearly, cloud native Java is one of the primary focus this foundation is having. So the foundation makes sure that cloud native Java application development has first class support. It has all the good features. It has the support for the security diagnostics and all the cool user experience and things like that. Next one, please. OpenGenine is the second piece of thing. If you remember the first recipe slide, we talked about first class Java support, first class Java runtime, which is optimized for the cloud. As we know, the Java is 25 plus years old, needs some customizations, optimizations by leveraging what is the execution environment that the container or the cloud platform is providing. So we look at some of the premises, some of the founding principles. You have Java heap, which is bounded by XMX. You have number of threads, which is bounded by the number of CPUs in the system. You have other resource allocations based on the principles of 90s. But now container comes with its own liberty, its own restrictions. So you need to design the threads, you need to design the heap, the stack, everything based on what the container is providing, right? So the OpenJ9 is a community-driven open source version of Java, which is fully compliant with the JVM specification as well as the Java language API specification. Originally written by IBM, but it's fully open source now. It has special awareness injected into it to know that, okay, I'm running in the container, so I could exploit and leverage the best in the container and run with maximum efficiency. So what are those efficiencies? So we get 40, this is largely comparison with hotspot JVM, which is by far the most popular JVM. We get 42% faster startup. So when it comes to container workload, one of the main thing is how fast you can spin up a container, right? So you are scaling in response to growing demand, growing concurrency from the user base. Suddenly, one set of containers are not able to hold the load, so you want to spin up another set. And if you are able to come up with the containers in milliseconds as opposed to seconds and minutes, that is going to add value to the performance. So 42% faster startup, 28% faster ramp up. Ramp up is basically, it's not just getting the request and able to provide the response, but as we know, JVM is interpreted. It needs special optimization called just-in-time compilation to basically give you the desired throughput. So for that, we need to learn the application over a period of time called profiling and see what are the opportunities to improve the performance. So that the whole thing is called the ramp up time. Once that ramp up is done, this is as good as a native application. So we get 28% over the hotspot. And another thing is the memory footprint. Previously, you don't worry about the memory footprint. You take up 2 GB of Java key. You pre-allocate the whole memory because every memory belongs to you. Why should I be restricted? But container workload essentially don't follow that principle because container is running in the cloud and cloud is metered based on how much memory you are using. So every bit, byte, everything matters. As tiny as possible, you can spin up the container. Better for you, better money you are saving. So what we do is we look at the JVM, look at the API library, which are the things that is absolutely not required for a containerized workload. The AWT, the swing, the whole graphics is not going to run in the container. Why to carry all these things in the JVM, right? So strip it off. Keep only the web profile part of it because that is only what is going to run. Make it thin, lean, and mean so that the end users get a lot of efficiency in terms of money as well as the runtime performance. So that's OpenGenAI.
Yeah, so Jakarta EE, we renamed it, Java EE is renamed as Jakarta EE. So basically, Java EE, foundation is running this particular thing. Whatever you got from J2EE, which is being used as Jakarta EE. So it's same setup. It's for a big enterprise applications you want to develop. So you have all set of features, frameworks, supporting JAX-RS, supporting Spring Boot, and various other. Your enterprise application, whatever is required. So Jakarta EE provides, supported by a huge set of community, which has a specification modularized by JCP process, and through that you get various so many other options. You have
Yeah. So essentially,
yeah,
we know the J2EE, which is the enterprise edition of Java. The standard edition was good. It provides set of APIs for you to do the printf, scanf, file access, network access, etc. But when your application grows in the enterprise, you need additional capabilities like authentication, authorization, database connectivity, translating your data from XML to JSON, JSON to something else. And so many things are there when it comes to huge application. So that mandated an enterprise specification. And a specification essentially has 3 or 4 components. One is a document that describes what is a spec. Second is the API documentation. So multiple application wanting to get a capability, you need to have a signature, you need to have a spec for the API, how to call the API, what to expect as a return value and things like that. Then you need to have a compliance kit, something called TCK, Technology Compliance Kit. If you come up with, tomorrow you come up with a capability, you need to test it against the TCK to say that I am Jakarta EE or Java EE compliant, right? And the last one is a reference implementation, which aligns with the specification. Yeah. So this is absolutely, don't get confused. Jakarta EE is nothing but the Java EE. The renaming happened because Oracle sold or delegated the ownership and the maintenance of Java EE to Eclipse Foundation, because Eclipse Foundation is huge, Oracle is small compared to the enterprise edition ecosystem. But Oracle holds the copyright for Java. We couldn't use the same keyword, Java Enterprise Edition. That's where the renaming happened as Jakarta EE. So it's the same thing. But definitely once Jakarta EE took over, an explosion of development that happened, a lot of new capabilities, a lot of new standards and compliance that came into the picture.
You can see in the slides, you may not be seeing the word Java, because Java, the name comes with a lot of, tightly coupled with Oracle. So the community cannot use that term. So wherever you have, you can see all the Java technologies renamed, and this framework we renamed it.
For anything and everything you can think about is covered over there. So the whole idea is you don't reinvent the wheel when it comes to the Java development. Anything that you can think about from a big application perspective, connectivity, authentication, messaging, event-driven thing, collaboration through mail, batch application, web application, dependency injection, bean validation, WebSocket, everything, the transformation, everything is out there with a specific hierarchy, specific organization that has come into the picture. Most of them are the result of evolution over a period of time. It's not that we develop everything from scratch on a particular day, but based on the maturity level, based on the workload shift that happened over the period of time, we found the necessity that these modules are required, and the specification came into being.
So most of these, features are, standardized, and they all follow JCP process, and everything is standardized. Forward, backward compatibility, everything comes into picture. And for the developer's point of view, it gives the flexibility to choose whichever technology you wanted to use on your enterprise application. So this is what the actual the process of this Jakarta EE follows. So earlier it used to be a stringent process where you need to go through so many. You first decide the specification, then you go for the implementation. And right now it is a iterative model where you standardize, you implement, then come back, standardize, and certify. Anything else?
Yeah, I just want to focus or reiterate this fact, re-emphasize on earlier J2EE was dictated by Oracle. What is the specification, what is the capability, everything comes from top. We just use it. But now it is collaborative. It is done, it is iterated, debated, criticized, improvised in the community, completely in the open. So all developers' problems can be presented directly in the open, and we can control the way these specs wants to be matured. Absolutely, there is no overarching entity or overseeing entity who will dictate the things. So that would be the key value that I will take away between javax dot something to jakarta.x. That's the key transformation that we are looking at.
So basically, the micro profile, this community basically develops the microservices based applications, help the frameworks, formalize the frameworks which require for cloud native applications, how you can develop it. Jakarta EE provides large set of features. So in that you can segregate out a particular feature and how you can implement a particular feature as a microservice. So micro profile community basically works on formalizing the specifications, providing the solutions for developing Jakarta EE applications into micro profile applications, microservice applications. So basically, micro profile provides us, set of these are the set of features you can use in your microservices. So you can extend your extend your Jakarta EE features. You can incorporate into your microservice, and you can use those things along with the features provided by microprofile. Basically, this provides support for JAX-RS, support for JSON-B, JSON-P, as well as the React Native messaging. You have health check feature which comes along with if you create a micro profile application. If you develop a micro profile application, you have support for health check, metrics, open telemetry. So various. It is a very small list. I think there is some more which are in the process.
So two takeaways from this slide. One is exactly the answer to your question that this is huge. This is all good, but this is huge. How do I customize it for the microservice, my need? So I need a customized profile, a variant of the same Java EE. I want all the goodness of Java EE, the security, the compliance, open governance, collaboration, everything, but bring it down so that it is highly efficiently aligned for my microservice. So micro profile is the microservice profile of the Jakarta EE. It's the same thing, it's a subset, but customized for the specific workload scenario. That is the first takeaway. Second takeaway is if any of you attended Wednesday session on 12 factor, 15 factor by Rich, Haggerty and myself, we talked about the 12 factors which are the ingredients or the main recipe programming principle of the microservices. We change everything from the traditional monolith to bring it to the fundamental principles where microservices will run optimally in the cloud native platform. If you see these things, all these things or most of these things are aligned to one of those principles, right? And it is organized. The first one is a core web capability for running, hosting an endpoint, hosting a servlet, right? So the JAX-RS provides that capability. Configuration comes first. Code and config separate. That's one of the 12-factor principles. So everything you can think about aligned to those principles. Next one comes the next level of middleware capabilities. From the base servlet, you want next level of capabilities that is coming from OpenAPI, reactive programming, things like that, JWT. And then you also want to have observability, the health and metrics and things, which are add-on components. Everybody do not need it, but I want it. So I have those capabilities. So plug and play. So it is hierarchical. It's fully aligned with the 12 factors. So that's the second takeaway. Yeah. So Java EE is good, Jakarta EE is good, micro profile is good. So remember, these are specifications. These are not implementations. These are not code. These are plain English written rules and regulations and governance sentences. Somebody should come and implement these APIs or these capabilities. So, do we have a list of players? I don't think we deleted that, right?
Yeah.
Yeah. So the JBoss, the Tomcat, the Spring, the Quarkus, and Liberty, all these things are first-class Java runtime platforms. They try to implement the specification, either Java EE or the micro profile in their own way. So if you are aligned with the micro profile, you make sure two things. One is fully compliant, fully aligned with the principles of the specification. Secondly, is fully aligned with the microservice principles. So Open Liberty is an instance of microprofile, is an implementation of microprofile. It has a legacy from the WebSphere Liberty, and WebSphere Liberty inherits the legacy from IBM WebSphere, which is a monolith of 90s that covers everything. As you say, if you download and install one, you get a 2 GB jar file, and if you go to the lib directory, you see hundreds of other jar files. Nobody knows what those are for. It's not the case with only WebSphere, but most of the application servers have that problem. We don't know whether I can delete this and still my application will work or not. It may be addressing a corner case, but nobody knows. So tiny is required. Tininess is an absolute necessary. Compliance and security is also another requirement. So Open Liberty combines all the cool features of the 4 ingredients that we talk about. It belongs to the Eclipse Foundation. It can leverage the OpenGenine runtime efficiency when it runs in the container, and it is fully adherent to the Jakarta EE, and it also uh, first runtime to implement the microprofile. So these are the components or the platform, the execution environment, which are fully supported by the OpenLiberty. Spring is already giving this capability. So if it is aligned with the micro profile, what is the cool thing you can do is today you hosted in Spring. You wrote an application, you hosted in Spring. If you want to move it to something else, because Spring is not providing a security thing or a capability bug fixing things like that, you want to try it with another runtime. If it is aligned with the micro profile, it's just taking the deployment and hosting it in another runtime. So that's the cool thing. The Spring is already implementing, Liberty is also implementing, but they are mutually compatible as long as they align with the micro profile. If people are not aligning with the micro profile, then the compatibility becomes an issue.
But Spring is not a web container, right?
Yeah.
Liberty is a web container. You can deploy any kind of your client, REST clients, JAX-RS clients. Spring client also you can deploy it in that.
We are now coming back to developers. This is all good, but uh, how does it matter to a developer? So another story I want to share is I have a tendency to look at when I do a floor walkthrough. I look at what other developers are doing. Are they many people are working on different projects, but what technology they are using, what platform in which they are developing things, or how their daily life look like. So if I peep through, what I see is most of them are using either Unix console, which is PuTTY, or some IDE like Eclipse or IntelliJ, VS Code. It's the same thing. Somebody may be writing for the cloud, somebody may be writing for a Oracle database or some ERP solution, everything. But essentially, the interface may be similar. Sometimes, even if it is not similar, look at what they are doing, right? They may be writing code, they may be debugging the code, they may be fixing a problem, they may be testing a problem, they may be deploying, taking a code from one environment and putting it into another and testing, making sure everything is good, they are packaging. So the developer's life do not change drastically. They live in this confinement. So the point I want to drive here is cloud native foundation is good. So many players, so many investments, so many community members and governing bodies and spec and all those things. How does it affect the developer's life? So how these tools and frameworks are going to help us with testing your code, developing your code, and debugging and running through the whole software development life cycle. So that is something very interesting because that is what at the end of the day matters to the developers. Let's look at some of these frameworks and tools that we talked about, how that is going to translate or transform to ease the developer's life.
So if you go to that this website and microprofile.io, this is the community where you can you can find all sort of details about microprofiles. Here you have you have a starter code. You can generate a starter code. So basically here you can generate a starter code for the various features we have seen previously. So here you can select the version of microprofile. So far it is 5 and 6 is about to come. And you can see the features supported on MPM microprofile 5. So on clicking any of these, whichever whichever feature you want. For example, you want to have a configuration microprofile separately. You can click the configuration. Also, you want to have a health check APIs to be added to your microservices. Then you can use this option to generate the starter code. Basically, this starter code can be deployed into Liberty. So Liberty compliant starter code you will get. You can choose the Java version, whichever version you want. On clicking download, you will get a starter code with the complete project, which you can load it into any of your IDEs, and I'll show you that. For the interest of time, I have downloaded the project, and I wanted to show you one more thing.
Network is really slow here.
Yeah. So you can also download open liberty based projects, and either Maven or Gradle. So this also, I mean, based on the Jaka, I mean, if you are using Java EE, that is Jakarta EE, and you can also have your project contains some set of micro profile addition. You can use this interface to download a starter project, basically. For interest of time, I have the project downloaded and loaded them here. This is my VS Code. So basically, for developers, increase the developers' productivity. So you get a starter project, uh, which I show you the one which I downloaded. See this, I selected all of them, whatever you saw in this particular page. The micro profile page. So here you have the client, where the client you have the REST client. Uh, you get the starter code here. You can extend it if you want. Similarly, you have a config services. Basically, you'll have a config properties defined in multiple places. So this config service you can collate, and you don't need to change your microservice if your configuration changes. You just change the configuration outside, but the profile, this config profile within your microservice, no need to be changed. So this config feature will help you fetch all the properties wherever it is, either from environment or from property file and things like that. Yeah.
So I work for both Java and Node.js, and many times we want to test some capabilities or some piece of code by writing a servlet for a web application. So suddenly I realize that I don't have a framework, or I don't have that servlet piece of code. So if I start writing from scratch, Node.js, it's 5 lines of code. In Java, you need to write the whole framework, or it can be little tricky if you are writing from scratch. If you are a seasoned developer, it will come handy. You know what all the recipes are there. But if you are a little less experienced, you know how much painful it can be. So it's always good to have a starter application which will give you the whole template, and you just need to inject your piece of business logic into that. That can be one of the uh, main game changer for a developer's daily life point of view.
Okay. I don't want to go through each and every feature I have. Download. I just show you the health check. Health check APIs comes in handy when you download a starter project. So you can do a live check, system check, and startup check. So all these health check things which comes in handy. So for IDE perspective, for Eclipse, IntelliJ, and Visual Code, we provide a plugin or an extension specific to that particular IDE to support or to ease the developers' productivity better. So we have a thing called Liberty Tools. The Liberty Tools, I don't know how many of you used it. So if you downloaded the Liberty Tools on your particular IDE, so as soon as you load your micro profile or Open Liberty project, you'll get a dashboard with what are the projects are present in the particular project you loaded. So basically, it has been detected based on server.xml, which is available in the particular project. So based on the server.xml, this Liberty dashboard popped up with the list of projects. So on right clicking, you get the option to start a project. Start means you are going to deploy this particular project into Open Liberty and you can on the fly you can make the changes. You can get the results. I mean, you can make sure that the changes you made is right or wrong. And just clicking start. So basically, it will start building your project, create a war file, deploy it into Liberty. So it will take some time. So in the meanwhile, I'll tell you how this works. So basically, you have a plugin, Liberty Maven plugin. So you have to incorporate this Liberty Maven plugin, which gives this capability that it automatically gets the Liberty for you, Liberty server for you, and then it does the packaging, and then it deploys the uh, service into the Liberty. So so this is a inbuilt. I mean, you can make change, and it automatically updates this particular run. For example, uh, yeah, the health check. For example, if I'm making some mistake and save it, so automatically it tells you where the error is. You can go and fix it. So it's a inbuilt. You no need to stop the server, start the server. You no need to redeploy it. It automatically happens. It's a dev mode. It also has the capability to deploy the service into containers. So if you have your Docker running on your machine, so this automatically creates the image and deploy it into a container. For example, yeah.
Yeah. So it, for me, it depends on what each vendors are focusing on, right? Some of them focus on runtime efficiency. Some of them focus on community support and stability. Some of them focus on developer productivity. So many perspectives are there. I don't know too much details about Quarkus, but I would say that this aspect of the open liberty, what we are talking about, is fully focused on how to improve the uh, experience, developer experience. Because the older way of doing this is you build you try in the IDE, then you bundle it and go to the other machine or other terminal, stop the server, go to the location where this should be deployed, put it there and restart the server, access the web page and see the result. That was the one which I know, and that is all completely short circuited here. You are doing everything in the IDE. And when it comes to the container, again, uh, you stop the container. If you have a mount, you place this war file, whatever, in the mount point. Otherwise, you use other mechanism to transport this into the container, re-image it, and start the container. So the whole thing is bypassed here. So we are not actually head-to-head comparing Quarkus with OpenLiberty on other various parameters like what are the feature-wise comparison, what is the other sophistication. Okay. Yeah. Yeah. Okay. I don't know. I don't know on top of my head. We can check about that. Yeah. At least in this session, we are not covering that aspect. Yeah. There is one aspect which will address that question, like uh, these are still okay. Microservice is still okay. Still, I see a lot of modules and components and jar files. Can I compose my liberty? I know how my application is going to be. What are the areas my application is going to touch? So I don't want the whole Quarkus or whole liberty. I can go and pick choose the modules. I don't want, say, the JSON. I'm not touching JSON. So let's remove that module from the runtime itself. So that capability is there in Liberty. Basically, further customizing so that your runtime is exactly matching your requirement. Yeah.
Okay, so I told about containers. So there's an option here itself. You can the start in container. Basically, this will find out your Docker daemon which is running on your machine, and then it will compile your project, package it, create an image, deploy that image into the Docker, and then give you it automatically executes that container, and you can test it out on the fly when you are developing. So this same, I just wanted to show you few code completion things which are supported by these Liberty tools. So if you look at, for example, I am just removing this liveness check for the time being. I just wanted to load this health check. So health check is not, right now it does not have a liveness check. On a right click command space, you can generate the micro profile liveness check on the fly. So you have a class which comes up automatically, creates a liveness check, and you can just come here and refresh this page, you get a liveness check. So similarly, you can also create REST methods. On right click, you type REST, you get what are the methods you wanted to add, you can add them. For example, if you want to add post method, I can automatically add them. So this also provides support for adding, finding out the bugs which while you develop. For example, the post method supposed to be public, so I am converting into private. 1 minute, yeah. So basically, it's supposed to tell you what you need to do. So it will give you the quick fix to fix the things on the while you are developing. So it also the quick fix, code completion is available for server.xml, as well as in the Liberty you will have server.env, also the bootstrap.properties. So everywhere you have code completion. So for example, here if you want to add a micro profile metrics, so you can add them. You can and this automatically takes care of on the fly development. So this is about code completion. You can also add features, add a feature. So here you can add, for example, servlet hyphen.
Mohan, there is a question.
Yeah.
What is a command that is used to containerize the application?
Okay, yeah, I'll tell you that. So all these right click, this dashboard options, which are all invokes the command. So the command is mvn liberty:dev, liberty:dev c. So you just need to have a Docker file. You want to Dockerize this particular service, just create a Docker file. Then Liberty tool takes care of running the Docker, creating an image, deploying it into the Docker daemon which is running. I think, if you are going to use that service within Liberty, just add this plugin, to your pom.xml, this Liberty Maven plugin, so which takes care of providing the Dockerizing your service into Docker. Yes, you can use Gradle also. Yes. If you are going to deploy that service into Liberty, then use this plugin, and this plugin takes care of deploying that service into Liberty. I'm not getting. You're going to create an image. Creating an image of using Liberty container as a Liberty container. I mean, if you are using the Liberty container, then you can use this plugin. I mean, Liberty Maven. I think if you are using other containers other than Liberty, I don't think so. You can do that. Yeah. Yes.
Yeah, the thing that we can derive from here is, as he said, this is a right-click button menu item which is internally being translated to MVN liberty.dev, whatever.
Yes.
So that's the learning, or that's the abstraction that we are hiding from the developer and showing some cool feature here. So in your case, use the same top-level abstraction in the IDE, but under the cover, do what it takes for your plugin or your environment. So it may not be possible with this plugin, but the learning can be reused as it is.
Yeah, I mean, this is only Liberty Tools. I mean, Liberty Tools support for this particular IDE. So the similar options available for Eclipse as well. As Eclipse Marketplace has Liberty Tools for Eclipse, you download and install it for your project, and as soon as you install a project, you will get an option here. So similar to VS Code, this also find out whether a project is a Liberty project. I mean, you can use the Liberty profile for deployment. So here also you will get all the options. Similar to your Java development, this runners also comes up with all the options which you can use it to start and stop, run a test. So all these options comes as part of your run as option.
Yeah.
So this plugin provides the option. So similarly, this Liberty tools available for IntelliJ. So maybe the IntelliJ users also can download Marketplace. I mean the plugin from Marketplace and use it. Yes.
So the whole idea, just to conclude, we looked at the cloud native programming landscape, which is huge, and then we talked about the implications to the developer. We visited the daily life of a developer and what are the activities or what are the communities, governing bodies, tools and frameworks that are aligned themselves for the cloud computing landscape. And we took a specific instance of Open Liberty and how it has transformed itself to meet some of the needs of the developer. The key learning here is this is all happening in the open. This is not an offering. This is an open source community development. So the requirements that you talked about, the specific pluggability, extensibility, or working with third-party components and images, all these things are developed in the open. So if there is a strong requirement for that, this can be debated in the GitHub out there in the open. So that is the message we also wanted to pass of Eclipse Foundation, the OpenJ9, micro profile, everything is open. So based on your requirement, based on the specific need, we can go and raise the RFPs and feature requirements. We can also have a look at what are the capabilities and what is the development process that's happening, how the community is interacting, how the landscape is changing for improving the developer's life, along with some other things like the operational efficiency. So having part of it improves the overall breadth and depth of your own understanding about the landscape, and that is one of the great experience as a developer, as a Java developer we can have from the community. So that's the message we want to leave here. Any feedback, any suggestions, any improvement areas from the cloud computing or Java EE, Java microservice development, cloud native development, please pass it directly to us or pass it over the community. We are happy to take it up from there and apply that as applicable. Thank you very much, everybody, for joining this.